All right, we're going to use this shorthand. So give me the shorthand for fluorine and chlorine. What was the last one we passed for fluorine? Last noble gas we passed. So noble gases are these on the end. So when I'm following the numbers, 1, 2, 3, 4, and I'm just following those numbers up top, right? These numbers in each box. 2, 3, 4. So what I'm going here, what was the last one I passed? It was over here. Helium.
Oh, okay.
So we take helium, we put it in brackets. And then we'll start up after helium. So helium was at 2, so now we're going to start at 3. And we're going to go across, so we're in the second row in the S's, so these will be 2S. Takes 2 to get across. Then we have the second row in the P's. And it's going to take 5 to hit fluorine. All right, so let's do chlorine then. What was the last noble gas that we would pass on our way to chlorine?
And the noble gases are.
That last column.
Would it still be helium?
No?
No, or boron? No, I don't know.
The noble gases
Oh,
are
I'm looking
these,
at the- sorry, I'm
and we're looking for chlorine.
It was.
Oh, you were looking at carbon. I got you.
Yeah.
I got you. Chlorine.
Would it be neon?
It's neon. That's the last one we passed. And what's it going to be after neon? So neon was at 10, we're starting at 11. We're starting at sodium. We're working our way to chlorine. So what's it going to be? We're going across. You'll notice what we did was when we do these, we're always starting on the row that what we're looking for is on. Because the last noble gas was everything before that row. And then we're going to go across to this row. So as we go across this row, tell me what to write.
3S2.
3S2.
And then we need to go to, can we go straight to the P?
Yep, because after 12 is 13.
And then it would be P.
Which piece?
Oh, no, wait. 5. P. 5.
So 5P5, that would be on the 5th row.
Oh, no, sorry. 3P.
3P5. Third row. In the P's, the 5th one over. Matter of fact, when we do bromine, we did it a while ago, right? And we said it was argon, 4S2, 3D10, 4P5. And we start to see some patterns here that these look very similar. Matter of fact, when I look at the electrons on the outside, so don't forget that these N numbers, these numbers here, tell me what layer we're on. I could put my, yep. I can draw circles. All right, so what this is saying is Here's the 1 S's, and we get N equal to 2. And so this is saying this one has got 1, 2, 3, 4, 5, 6, 7 on that outside layer. That's fluorine. And then when I look at chlorine, it says go ahead and fill this one up. And then you got 1, 2, 3, 4, 5, 6, 7 on the outside layer. All right? I'm just taking this 2 plus this 5 until I get to 7. How many are on the outside layer for the bromine? Remember, this is 1 layer down. This is on that 3rd row. Well, I'm looking at the biggest numbers in the front. So how many electrons would be in the outside layer? Oh, I got 2 here and 5 there. How many? 7. So all of these have 7 on the outside layer. So that outside layer of electrons, the outside electrons, we'll call those valence electrons. And they're really important. And the reason why they're so important is that's where the reaction statements is on the outside. And our picture for reactions will always be that when these atoms want to react, it's the outside that does it. So they bang into each other. And so it's the outside layers. So if you bump into somebody in the hallway, it's the outside of you interacting with the outside of them. Same kind of idea as this. Yeah. So what happens then, fluorine, chlorine, and bromine, they have similar electron configurations. They're all in the same row, right? They all end in that P5. And so they have very similar chemistry. Same kind of thing when I'm over here for these 2s1 and 3s1 and 4s1 and 5s1 and 6. These all have just 1 electron on the outside for group 1. Well, these only have 1. And so they all have very similar chemistry. We'll come back to that. Now, before we leave electron configurations, I want to make sure we hit some of the harder ones. And that's what we talk about when we deal with ions. Ions are an atom, like an atom with a charge. If I do oxygen with a -1 charge, there's 2 ways for me to find its electron configuration. The first way is I find oxygen when it's neutral, and then I add an electron. Keep in mind, when it's a -1 charge, you add 1 electron. If it's a -2, you would add 2 electrons. If it's a +1, you subtract. And that seems backwards to us at first until we remember that electrons have a negative charge. So this one, if I do the electron configuration for oxygen, so oxygen itself is 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. Okay. So then I'm going to add an electron. I got to decide where it goes. So it's going to go on the outside, and we're going to, this p still has room. How many can p's hold? 6. This one only has 4, so I'm going to add 1 plus 1 electron, and I get 1s2, 2s2, 2p5. But there's an easier way of doing this. I'm going to apply the off-ball principle directly when I do these. So they asked me to go to oxygen, but what kind of charge was it? A negative. And so if it's a negative charge, I add an electron. In other words, I go forward a box. If it's a positive charge, I go back a box. All right, and so it's a -1, I go forward 1 box. So I can just do my electron configuration of fluorine, which is 1s2, 2s2, 2p5. So these two have the same electronic configuration. That's called isoelectron. Isoelectron. Iso means same. So they're saying they have the same electron configuration. So if I did magnesium with a +2 charge, I want to know what is it isoelectron. So we find magnesium. Here it is at 12. I want to know what is it going to be isoelectronic. So which way are we moving? So I'm going to move this way. I'm going to add electrons. Am I subtracting electrons?
Well, it looks like you're adding it. It's positive.
It's positive, but remember it is positive too. We're saying we've got 12 protons because it's magnesium. That's what that 12 tells me. And I have so many electrons that I cancel all 12 of those except 2. So how many electrons do I have? I actually only have 10 electrons. If I had 12, it would be 0, right? And if I had added 2, I'd be to get 14, I'd have a -2 charge. That always seems backwards, so remember electrons have a negative charge. That's the key to chapter 2. So this one, which way are we going? We're actually going 2 boxes back. So where will that put me?
Well, now, can you go down, or I don't know?
We're going to follow the numbers.
Okay, so you would go to neon.
I'd go to neon. And that's kind of the thing we want to remember is that these connect right after neon and sodium. They wrap around. A lot of people take this and when they're teaching, they put it on like a cardboard roll so you can see where after 10 is 11. But it's easier just to think we follow the numbers.